In this last section, we're going to return to graphing ellipses which aren't in standard form. So here's an example. Graph the ellipse with this equation. Now this is going to be more complicated than the last one we did, and let me show you why. The last one we did, where we wrote the equation of an ellipse which wasn't in standard form, this was how we started. And it was really easy to get it in standard form because this side wasn't equal to 1, and by dividing by this constant, by dividing all the terms by 100, we were able to put the ellipse in standard form in one move. Let's take a look at this first example that we have in this section. Can you see that just dividing everything by 100 isn't going to work here? So what we need to do in this problem is do a technique which is called completing the square. Now, you may have done this before in a previous math class, so hopefully it'll sound familiar, but if not, it's not difficult to do, it's just a little tedious. So the first thing you're going to do is you're going to move the constant. You're going to move it to the other side of the equation. So we're going to start this problem by subtracting 100 from each side. So let me rewrite it so we have more room. And let's do two things at one time. We're going to move the constant and group the terms by variable. Meaning we're going to put all the x terms together, all the y terms together as we move the constant. So we're starting off with 4x squared. The next thing we're going to put is negative 40x. Then we have 9y squared. And the next thing we're going to put is positive 36y. So we've grouped the terms by variable. And to move the constant, we would subtract 100 from each side. And so our equation would look like this. The next thing we're going to do is we're going to factor out the lead coefficients. So we're going to rewrite this as 4 times x squared minus 10x plus 9 times y squared plus 4y equals negative 100. And now we're going to complete the square. So to complete the square, you do a series of steps. You take half the linear coefficient, you square it, and you add to both sides. All right, so here we go. The linear coefficient is the coefficient of the linear term. So here we have 10. Half of 10 is 5. And if we square that, we're going to get 25. So we're going to add 25 here. But because it's inside of parentheses, we're really going to add 100 on the other side because we're really adding 4 times 25 on the left side. Here, let's try that with y. So here we have a 4. Half of 4 is 2. 2 squared is 4. We're going to add 4 here, but on the other side, we're going to add 36. All right, now why do we do that? Because now you have a perfect square quadratic. So let's go ahead and see what we have. So here we have 4, and this piece right here will factor as x minus 5 times x minus 5. In other words, x minus 5 squared. That's why this is called completing the square. Here we have 9 times, and this piece here will factor as y plus 2 times y plus 2. In other words, y plus 2 squared is equal to, and if we combine all of these terms, we have 36. Remember, standard form is equal to 1. So we'll divide all the terms by 36. And now we have our ellipse in standard form. X minus 5 squared over 4 divided by 36 is 1/9 plus y plus 2 squared. 9 divided by 36 is 1/4 is equal to 1. So now this ellipse is in standard form, and we can go ahead and graph it. So let me write it down here next to the graph, x minus 5 squared over 9 plus y plus 2 squared over 4 is equal to 1. I'll help you get started, and then I'm going to have you finish it yourself. So the axis, I'm just trying to make an axis so I think it'll fit on the graph. Let's see if this one will work. Okay, so I know that the center, what are we subtracting from x? 5. What are we subtracting from y? -2. So this ellipse is going to be centered at the point 5, -2. So why don't you see if you can go ahead and sketch what the ellipse is going to look like. Fill in how many spaces are we going to move in the x direction, how many spaces are we going to move in the y direction. So why don't you just go ahead and graph the ellipse. We won't worry about discussing the foci for this one. Okay, let's make sure you were able to graph it. So in the x direction, if we look under the x term, we see 9. The square root of 9 is 3. So in the x direction from the center, you go out 3 units in each direction. In the y direction, we go the square root of 4, which is 2. So in the y direction, we go 2 units, and here's a graph of that ellipse. Let's try one more of those. Okay, so we're going to graph this ellipse. So again, our first step is to move the constant and group the terms. If we do that, we're going to have 4x squared minus 24x plus y squared plus 2y is equal to -21. All right, we're going to factor out the lead coefficient. So for x, we're going to factor out the 4. So that's going to give us x squared plus 6x. Notice that there is no lead coefficient in y, so we don't have to worry about that one. And that's our second step. Now we're going to actually complete the square. So we have to look at our linear term, coefficient. Half of 6 is 3. 3 squared is 9. So we're going to add 9 here. But on the other side, we're going to add 36. Here, half of 2 is 1. 1 squared is 1. So we're going to add 1 here, and we're going to add 1 here. All right, so let's see what we have. We have 4 times, this is going to factor as x minus 3 times x minus 3, or in other words, x minus 3 squared. And this is y plus 1 squared, equals, and over here we have 16. Finishing touch, we want this equal to 1, so we divide all terms by 16. So we have x minus 3 squared over 4 plus y plus 1 squared over 16 is equal to 1. So here's a place where we can graph it. Let me transfer the equation down here. X minus 3 squared over 4 plus y plus 1 squared over 16 is equal to 1. Okay, I'm going to put an axis system here, and while I do that, why don't you figure out what the center of the ellipse is? Okay, let's check. Hopefully you said the center was x minus what? 3. Y minus what? -1. So this ellipse is going to be centered at 3, -1. Okay, go ahead and see if you can fill out the x direction, then the y direction, and this time let's see if we can find the coordinates of the foci. All right, let's check those for you. So looking under x, the square root of 4 is 2. So in the x direction from the center, go out 2 units in either direction. For the y direction, we have the square root of 16, which is 4. So in the y direction from the center, go out 4 units. And so here is a picture of the ellipse. Now notice that the vertical axis is the major axis, so the foci are going to be found on that axis. The distance to the foci is the square root of 16 minus 4, which is 12. And the square root of 12 is a little more than 3 units, so 1, 2, 3, a little more than 3. And we should actually simplify this. This is the square root of 4 times the square root of 3, or in other words, 2 square root 3. So if we wanted the coordinates of these, notice that they have the same x-coordinate as the center. So one coordinate is going to be 3, comma, and then from the y-coordinate of the center, you add 2 radical 3, and you also subtract 2 radical 3. So this one here is 3, comma, 1 plus, negative 1 plus 2 rad 3, and this one here is negative 1, comma, 3, comma, 1 minus 2 square root 3. So those are the foci.